Welcome to Quadratics Lesson number 6. In this lesson we'll be looking at some problem solving exam type questions. Typical in the National 5 paper, these are tricky questions that would tend to come up towards the end of the exam paper. Okay, so first one we're going to look at is the point of intersection of a line and a parabola, the points where the line and the parabola meet each other. Okay, so in this example you're given the two equations. We've got the line and the equation of the parabola there, and it says that they intersect at points P and Q. So at point P, the line and the parabola, they're equal to each other. Okay, point P, whatever the y value is for the line, it's the same y value for the parabola. So at points P and Q, it says there the y coordinate and the y coordinate for the line and the y coordinate of the parabola, they're exactly the same. Okay, so that means if the y values are the same, then these two must be equal to each other. Okay, if the y values are the same, they're equal. So we actually make up an equation. There's your parabola, and it's equal to the line, because at the point of intersection they are equal, they're the same point. This now is a quadratic. It doesn't look like any quadratics we've used so far. The method for solving quadratics that you've used up until now is we factorise, but we can't factorise anything like this. Our parabolas, our quadratics, they all always equal 0. Okay, so we need to make this equal to 0. Now, if this is going to be equal to 0, what we really need to do is bring these all across to the one side. Okay, so we're going to have an x squared, we've got the minus 4x, and we've got the plus 5, but we're also bringing across this minus x, bring it across, plus x, we're bringing across a plus 3, move it across, it's a minus 3. So what we actually have is x squared. Now collect the x's together, you've got minus 4x but plus x, minus 4 plus 1, so you've actually got minus 3x. And your numerical value, you've got a plus 5 and a minus 3, positive 5, take away 3, you've actually just got plus 2. That's a plus there. Right, that's a bit more used to the type of quadratics we've been using so far. So factorise, it says find, we need to work out the coordinates. Factorise, you know how to factorise this. Two numbers that multiply, this is one of your trinomials, factorise. Factorise to find the x value. Two numbers that multiply to positive 2, add up to negative 3. Well, two numbers that multiply to positive 2, 2 times 1, but they only add up to positive 3. 2 times 1, negative 2, negative 1. They multiply to positive 2 and they do add up to minus 3. So it's a minus 2 and a minus 3, minus 1 rather. Okay, these are your factors to get the solutions. Remember, to get your solutions, what do? We set both factors equal to 0. Now, if these are equal to 0, you're going to have x is 2 and x is 1. Okay, by setting each one equal to 0. That would be x minus 1 equals 0, move across the minus 1, so x equals 1. Okay, those are our x values, so that's our x values for P and Q. I actually said find the coordinates of points P and Q. So point P is obviously the one that's got x equals 1. We need to find the y value though as well. Okay, how do you find the y value? Well, you've actually got two equations. They're both going to give you the same answer no matter which equation you use. I'll choose the line equation, it's a wee bit easier to use. So it says negative x plus 3, that's the equation, that's how you work out y. Negative x, so negative 1, add on 3 is 2. So point P is actually the point, x is 1, y is 2. Point Q, well, Q is obviously the other one, x equals 2 at point Q. So how do you find the y value? Well, sub it in. So it's going to be negative 2, add on 3, negative 2 add on 3 is 1. So point Q is actually x is 2, y is 1. Point P, point Q. Okay, look at the graph, it looks right, it makes sense. I know it's just a sketch, but do use it to help you. Okay. Okay, another example we're going to look at again. These are typical problem-solving type exam questions. People would say they're the most difficult type of quadratic problems. They do tend to come up towards the end of the National 5 paper, okay? So in this one here, we've got a rectangular garden, the length is x plus 7 and the breadth is x plus 3. Show that the area is given by this function here. The area, well, this is a rectangle, remember, part A. How do we work out the area? Well, area, rectangle, length times breadth. What is the length? The length is x plus 7. What is the breadth? X plus 3. That's how we would write down that we're multiplying them together. I'll get a bracket around it, oh, just about. Doesn't quite look like that, but what can we do to make it look like that? Multiply it out. Okay, multiply out your brackets. X times x, x squared, x times 3, plus 3x, plus 7x, and plus 3 7s, 21. Altogether, what that actually says, x squared plus 10x plus 21. 21. Oh, and there you go. That's it. Part A is done. Show that the area is given by this. We've worked it out. Part B. That's part A. Part B. The area of the garden is actually 45. Find x. The area of the garden is 45. This here is the formula for the area of the garden. So if the area of the garden, which is given by this formula, if it's 45, then this formula equals 45. Okay? Like the last time, that does not look the typical quadratics that we see. The typical quadratic we see is where it says equal to 0. So bring it across onto the left-hand side. Minus a 45. Not quite like the typical quadratic we like to look at. Let's see, x squared plus 10x plus 21. Take away 45. Let's take away 24. And that's more like the typical quadratic we like. Okay, same as before. Two numbers multiply. This is your trinomial. Two numbers that multiply to negative 24. They add up to positive 10. Two 12s are 24. And yes, we're going to be able to get the 10. So let's see. Positive 12, negative 2, they multiply to minus 24 and they add up to positive 10. So that's your factors. Remember, you get your solutions by setting both parts equal to 0. So if x plus 12 is equal to 0, you're going to have x is actually negative 12. And on this factor, if x minus 2 is equal to 0, if x minus 2 is equal to 0, you're actually going to have x equals 2. So that's our two solutions, minus 12 and x equals 2. Do remember, it does say find x. What is x? X is a length, okay? X is a bit of a length of the breadth and the length of this garden. X is a measurement, it's a dimension. X can't be a negative number, we can have a negative length. So the only one that actually is correct here is x equals 2 metres. It is metres. X is 2 metres. You must make it very clear at the end that you're actually discounting this one. This is the answer. Okay, I'm going to set you some questions. These are quite challenging, typical towards the end of the National 5 paper exam questions. Have a go, please. Okay, good luck, and mind message me if you need any help.